To understand more of the predictive analytics of the Doherty set and how it applies to the electric universe model, I will now proceed to show off 10 real-world applications and examples of magnetohydrodynamic currents, flows, and patterns. But first, I will simplify our understanding of what exactly the Doherty set is. The set is simply the next iteration of the fruit of life and flower of life sequences that so many of us are already familiar with. The flower of life is an ancient motif found all over in temples and other holy places throughout the world. This concept is very important, but if you just take it one step further and take the fruit of life seen here and rotate it on top of itself, one layer after another layer, using the inverse square Bessel function as a parameter, it constructs the Doherty set. We will get more into this later in this episode when we explore Theodoretian roots. So that's how you construct the Doherty set. It's all 1 over r, just as Don Scott reiterated so eloquently in his latest video. Perhaps this geometry provides the rotation and origin of spin as Birkeland currents that Professor Don Scott just hypothesized as well. It certainly does make sense that this emergent dynamic geometry is fundamental in the construction of Birkeland currents. Since this show is all about magnetohydrodynamic flows, let's define what magnetohydrodynamics is. Magnetohydrodynamics is the study of the flow of electrically conducting fluids in the presence of magnetic fields. Models in which plasma is treated as a perfectly conducting fluid are the most successful models for describing the equilibrium and large-scale stability properties of magnetized plasmas. Examples of such magnetofluids include plasmas, liquid metals, salt water, and electrolytes, among others. We will probably get deeper into these flows in other episodes, but for now, we will begin with a simple water droplet in acoustic levitation. Have a look-see how each of the harmonics fit nested within the framework of the Doherty set, even as the frequency increases. These shapes are natural 3D cymatics. Now, let's imagine these shapes moving through tunnels. Not just any tunnels, but tunnels in space, connected directly to the universal electric circuit. These plasma tubes, or currents, do indeed exist and are called helicon waves. Waves exist and oftentimes make up the geometry of the entire structure of the current or flow. Helicon waves are what we see as the auroras, and yes, they have a sound, the literal sounds of the heavens. So when we're viewing the auroras, just know that they are literally 3D cymatics, which brings us to the next type of current, Birkeland currents. Intricate geometric patterns persist in and along Gaussian Bessel filaments, or Birkeland filaments. Like, for example, look at Saturn's North Pole. This hexagonal geometry was created by and persists due to Birkeland currents coming from the electric sun. Look at the similarities, all the way down to the petals that propel the counter-rotation. Let's bring it back down to Earth and talk about the geometry of lightning. Now, we would assume that this wave nested within wave behavior that is indicative of Birkeland currents would have a fundamental geometry that would allow it to efficiently distribute charge, and that this caduceus-like braiding would work all the way down into the filament of lightning. And indeed, it does. In a paper written by Wayne Byrne, titled Polygonal Crater Formation by Electrical Discharges, he shows that charge flows through lightning in hexagonal tubes, or sheaths, each layer in counter-rotation. This is similar to all the other flows that we've talked about thus far. Evidence of this geometry of polygonal cratering can be found all over the planets, including the moon. This process is also known as electrical scarification. Further proof of this geometrical process of charge and charge separation can be found in Theodoretian roots. Theodoretian roots are extremely easy to understand, and just like the water droplet, they increase the amount of sides incrementally along with the harmonics. First, charge neutrality seeks edges, as we just saw in lightning. Knowing that, we begin using regular polygons. Then we nest the polygons equally inside each other, giving us the inverse triangular, inverse square, inverse hexagonal, etc. geometries. We then bound or circumscribe the polygons, and this is what gives us the Bessel function. Each one of these Bessel functions is unique, just like our fingerprints and atomic uniqueness. From there, we iteratively repeat the Bessel function, cascading outward from the initial Bessel function. It is this projective geometric construction that forms the filament. This is how to build the Doherty set and the first principal geometries of Birkeland current formation. It is all cavitating. Along these filaments, constructive and destructive wave interference also occurs, which is largely responsible for the reality we experience. Destructive interference is when two waves traveling in the same direction are aligned at the crest of one wave and the trough of the other. The waves cancel out. Constructive interference is when two waves traveling in the same direction overlap, and their crests combine to produce a larger wave. For the next flow, we have vortices, chirality, and cavitation. First, observe our polar vortices in the magnetosphere. Now, observe the vortexture of the Doherty set overlaid. It's literally like a vorchestra. The vorchestra can be thought of like the fascia, the sheath of stringy connective tissue that surrounds every part of your body. It's electric and moves all of our thoughts through our body along this entire organ at the speed of light. But this vorchestra is on all scales, connecting everything in the cosmos. Another term for this is also the cosmic connectome. We can see the electromagnetic field creates the form, and the shape has power. The chirality of the vortex spinning clockwise or counterclockwise is another electromagnetic force often controlled by the Coriolis effect. These vortices form on all scales, from the galactic to the cavitation of microspires. For this next example, we will combine a few of the previously mentioned flows. In 2016, researchers discovered a new type of fire, blue whirls. Blue whirls are swirling flame phenomenon that evolves from a chaotic fire whirl and burns with nearly soot-free combustion. Supercomputer simulations have revealed the flame structure and flow structure of the blue whirl. At this point, I had already been sketching this shape for years, and I knew of its importance in the grand scheme of things. So in 2017, I published a paper exposing the taxonomy of opposed spiral vortices of the blue whirl to be composed of a set of 6 opposed spiral vortices. In 2019, a paper published by Cornell University shows that the vortexes of the blue whirl are composed of 3 different flames. And so we're getting somewhere with the predictive power of the set. Speaking of prediction, this geometry predicts that the base of Birkeland currents, or how a Birkeland current nests and stacks on the poles, is similar to the shape of a blue whirl. This heterodyning phase conjugate stacking reminds me of something else. Phase conjugation is multiples of the golden mean. Surprisingly, another current that this shape shows up in is in Elon Musk's SpaceX Raptor engine test. This particular shape is indicative of minimal energy configurations, and also shows up prominently in lens flares as well. A kink instability is a current-driven plasma instability characterized by transverse displacements of a plasma column's cross-section from its center of mass without any change in the characteristics of the plasma. So basically, it's extremely similar to the braiding of the caduceus as seen here in the Doherty set. This is the first 10 concatenations. Concatenations are just a series of interconnected things or events. Currently, there is an unknown amount of pairing and nesting of different sizes of kink instability on all scales. There's so much work that still needs to be done on mapping out the infinite amount of toroidal node helical coaxial coils. And I stress that I say toroidal node because the helical filaments are centered by nested torus, and these nested torus are also the repeating cosmic Bessel function that any source star gives off. For this last example, we have branching systems, roots, trees, distribution of matter in the universe, Lichtenberg flow, or dendritic arborization. It's been called many different things. This shape takes place in many living things throughout the universe. It's one of the shapes that remind us that everything is electric. Our synaptic brain activity, our veins, our organs, and even the hypothesized dark matter that is actually a Birkeland polyphase web. So many things take on this beautiful shape in nature. Lichtenberg flows are often a sign of living systems or a vestige that living systems were once there. All in all, cosmology is gorgeous and filled with myriad flows. And once again, it is self-evident that the Doherty set and the EU model itself provide a framework to help us understand the intricate dynamic geometries of magnetohydrodynamics on all scales, from the micro to the macro.